In Chapter 6, Section 2, we are factoring trinomials. Our objectives are to factor trinomials when the coefficient of the second degree term is 1, and that we consider to be a simple trinomial. We can factor trinomials with the coefficient of the second degree term is not 1. We're going to use an AC method for that. And we're going to use an alternative method for factoring trinomials and factor by substitution. This slide shows a general strategy for factoring polynomials, and this is available in the Blackboard website for those of you taking this course online. So the first thing you want to do when you are looking at polynomials is to first factor out any greatest common factor, and we practiced that strategy in the last section. We also looked at factoring when you have 4 terms. When you have 4 terms, factoring by grouping is a common approach to factoring those types of problems, and we have an example listed here. Now in this section, we're really going to be looking at factoring trinomials. That's where we have 3 terms in the polynomial, and we want to look at the different possibilities. If it's a perfect square trinomial, then the first term is a perfect square and the last term is a perfect square, and the middle term is 2 times the first and second term, then that is considered a perfect square trinomial, and that could be factored in this way, either the quantity a plus b squared or the quantity a minus b squared. We'll look at a few examples of that. And then what we're going to focus on in the first part of this section is whether the trinomial is a simple trinomial. And a simple trinomial means that the coefficient of the squared term is 1. There's nothing in front of the x squared term, so we understand that to be 1. And the way we're going to factor those types of trinomials is by looking at this last term, the constant term. And we want to find the pair of numbers that are factors of c that will add up to that middle term being b. So here's an example of factoring a trinomial. We have x squared plus 3x plus 2. We look at the c term, which is a positive 2, and we look at the pairs of factors of positive 2. Now the pair of factor of positive 2 is 2 times 1. And we want to find the pair of factors that add up to b, that middle term. And the same pair of factors that multiply to give you positive 2 will add to give you positive 3. So this trinomial can be factored as 1 factor of x plus 2 and 1 factor of x plus 1. And you can use the FOIL process of multiplying binomials to check to see if you were to use the first, outer, inner, last for these 2 factors, you would end up with the original trinomial. So in factoring trinomials, we're doing the opposite of that first, outer, inner, last process. Later on in this section, we'll be looking at trinomials that are not considered to be simple trinomials. And that's when you have a coefficient in front of the x squared term, and then we'll be looking at the AC method, which we'll get to later on in this video. The product of 2 binomials sometimes gives us a trinomial. Again, recall that we use the FOIL process, the first, the outer, the inner, and the last when we're multiplying a binomial times a binomial. And oftentimes when we use the FOIL process, the outer and the inner terms will combine to give you the middle term, because they're like terms. So we have 2 processes that will undo each other. When we are multiplying, we are getting the product. We're taking 2 binomials, multiply to give us a trinomial. In the factoring, we're going in reverse. We are starting with the trinomial and working back to get the original 2 factors. Now, factoring trinomials when the coefficient of the square term is 1 involves this 2-step process. You want to find pairs of pairs whose product is C. So again, we're looking at that last term C. Find a pair of factors whose product is C. And the step 2 is a find of the pairs from those products that if you add the terms, that the sum is B, that middle coefficient. And then you're going to choose the pair whose sum is B. And if there are no such possibilities, we say that the polynomial cannot be factored. A polynomial that cannot be factored with integer coefficients is a prime polynomial. And here are some examples of trinomials that cannot be factored. Let's look at these examples and determine why they're considered prime. Well, in this case, the C term here, in this case, C is equal to 2. We want to list all the factors of 2. And the factors of 2 are 1 times 2 or negative 1 times negative 2. Now we want to find the pair of factors that will add up to the middle term. The middle term coefficient is B. So B, in this case, is equal to 1. There are no pairs of factors of C that will add up to give you B of 1, because 1 plus 2 is equal to 3, and negative 1 plus negative 2 is equal to negative 3. There's no possible factors of C in this example that will add to give you B in this example of 1. The same thing goes for the other two. Looking at the last term here of negative 1, there are no pairs of factors of negative 1 that will give you that middle term. In this case, C is equal to negative 1 and B is equal to negative 1. So you want to find factors of C being 1 times negative 1. If you add the factors of C together, you get 1 plus negative 1, you get 0. But we're looking for the pair that will add up to the middle term. So we consider that to be prime. Factoring trinomials in x squared plus bx plus c form. Let's factor this polynomial using the two-step process given. Here, our polynomial is written in standard form. The a is equal to 1. The b is equal to negative 4. And the c is equal to negative 32. Now we list the factors of C in pairs. So that's going to be our first step. List factors of C. Now C is negative 32. So let's write negative 32 over here and then make a list of possible factors. So let's begin with negative 1 times 32. Well, we know if the last term is a negative, in order to get a negative by multiplying, you have to have a positive times a negative or a negative times a positive. So negative 1 times 32 is one possible pair of factors. The next one is negative 2 times 16, negative 4 times 8, negative 8 times 4, negative 16 times a positive 2, and then finally the last pair would be negative 32 times positive 1. Now out of all these pairs of factors, we want to find the pair that will add up to the middle term. The pairs of factors of negative 32, we wanted to add up to negative 4. And the pair that do that is the negative 8 and a positive 4. So our polynomial can be expressed in factored form as one factor of x minus 8 and one factor of x plus 4. We're finding the pair of factors that will multiply to give you negative 32, and when you add them together, negative 8 plus a positive 4 will give you a negative 4. And we want the pair of factors that will add up to the middle term. This is how we would write our polynomial in factored form. The way we check our answer is by using the reverse of factoring. In this case, the reverse of factoring is the FOIL process. So the first, outer, inner, and last, we have x times x is x squared. The outer is x times a positive 4. X times 4 is plus 4x. The inner is negative 8 times x. That's minus 8x. And the last is negative 8 times a positive 4, which is negative 32. And recall, when we're doing the FOIL process, often the outer and the inner terms are like terms, and we get the combination of x squared, or the final trinomial is x squared minus 4x minus 32. So this is our check, and that's what we started off with. Our original trinomial, x squared minus 4x minus 32, can be factored into the quantity x minus 8 times the quantity x plus 4. Now, if the last term is positive, the last term being c, if c is positive or c is greater than 0, then the factors will be in the form of x plus something, something plus something, because a positive times a positive is a positive. Also, a negative times a negative is a positive. So those are the two possibilities if that last term is positive. If the last term is negative, then the signs are going to be the opposite, because a positive times a negative is a negative, and a negative times a positive is a negative. Let's look at this where we're factoring a trinomial that has a common factor. Now, the first thing you're doing when you're factoring is to make sure that you've factored out a greatest common factor. And notice that we have a common factor of 3. 3 goes into all of those coefficients. All of these terms have a common factor of q, and the smallest exponent of q is 1. So before factoring the trinomial into the two binomial factors, we find the GCF. The GCF in this case would be 3q to the first. So we're going to factor out the 3q in the beginning, and then we'll have a trinomial in the parentheses that will factor using the simple trinomial factoring form. So when you factor out the 3q, you're dividing out. 3 divided by 3 is 1, and q to the third divided by q to the first is q to the second power. And 12 divided by 3 is 4, so that's going to be a plus 4. Q to the second power divided by q is q, and m is left there. And the last term, negative 36 divided by 3 is negative 12. Q will divide out, followed by m squared. Now we want to find the final factored form, and since this is a trinomial, those three terms, it may be possible to find the two binomial factors. Now if we have a q to begin with, we're going to have a q plus or minus something as one factor, a q plus or minus something as another factor. Now the last term has an m, so we'll have an m squared actually. So in order to get that m squared, you need an m in one part of the factor here and an m in the other part of the factor. So let's look at the quantities of the values for b and c within this, inside this trinomial. So looking at the c in this case, c is equal to negative 12. This is, the inside here is considered to be a simple trinomial. So our c is negative 12, and our b is a positive 4. So we want to list the pairs of factors of c that will add up to b. And negative 12 can be written as negative 1 times a positive 12, negative 2 times a positive 6, negative 3 times a positive 4, negative 4 times a positive 3, negative 6 times positive 2, and finally negative 12 times positive 1. And we want to find the pair of these factors that will add up to a positive 4. And that pair of factors is negative 2 and a positive 6, because negative 2 plus 6 gives you a positive 4. So our factors here are going to be q minus 2m and q plus 6m, and in addition to our 3q, which was the greatest common factor. Now the way you can check this is by using the FOIL process and then finally distributing the last term. So if we do the FOIL and first, and then at the end we will, at the end we will distribute the 3q. So let's leave the 3q out in front, and then inside here we're going to do the FOIL process. The first q times q is q squared. The outer q times a plus 6m is plus 6mq. The inner negative 2m times q is minus 2mq. And the last term is negative 2m times a positive 6m, and that is a minus 12m squared. We can then combine like terms, q squared being the first term in this inside trinomial. We have a plus 6mq minus a 2mq, that's a plus 4mq, followed by a minus 12m squared. Okay, now, in our last step, we can distribute, and then, again, this is the check step. The original factored form is written like this, and then the next steps following is the check to make sure we end up with what we started with. When we distribute the 3q, we get 3q to the third power. 3q times 4mq is 12mq to the second power, and then 3q times this minus 12m squared is minus 36qm squared. And that's what we started off with. Only difference is this m and the q squared are written in just a different order, but it is equivalent. Now the way we factor trinomials when the coefficient of the squared term is not 1 involves a different approach. You can try the guess and check method, but we need to consider the different ways that you can write the 3x squared term. We're searching for the pair of factors here that when you work and do the FOIL, you will end up with 3x squared minus x minus 2. So the way you get that first term can be written as 3x times x, getting the 3x squared, and then the way you get that last term from negative 2 could be negative 1 times a positive 2, or negative 2 times a positive 1. But the process involves guessing and checking your work using the FOIL. So rather than do the guess and check process, because it's not always efficient, I want to present here the AC method for factoring trinomials when the coefficient of the squared term is not 1. So the AC method. In doing the AC method here, we multiply A and C together. So A in this case is equal to the first coefficient of the x squared term, which is 3. The B is the middle coefficient, the coefficient of the x term, which is negative 1, and C is the constant term here, which is negative 2. We multiply the A and C together, so A times C is equal to 3 times negative 2, which is equal to negative 6. Now we list the pairs of factors of negative 6. So list pairs of factors of AC. So negative 6 can be written as negative 1 times 6, negative 2 times 3, negative 3 times 2, and negative 6 times 1. And we find the pair of factors of AC that add up to the middle term. The middle term here being negative 1. Which pair of factors of AC will add up to the B term of negative 1? The pair of factors that add up to B are negative 3 and positive 2. Now, when we find that pair that add to the middle term, the pair of factors that adds up to the middle term of b, is then we split the middle term and then we finally factor by grouping, which we went over in the last section. So again, this is an alternative to the guess and check. So rather than use this method, I'm going to erase this guess and check method here and use the AC method to solve this, factor this trinomial. So we did AC, we found the factors, we're going to split up the middle term. The first term remains the same. We write the first term as 3x squared. The middle term, we are going to split it up into two terms using the pair of factors of AC that add up to the middle term. And that is going to be negative 3x and a plus 2x. We're essentially finding the outer and the inner here. And then our last term, we split up that middle term into those two terms, and then we factor by grouping. Looking at the first group, we see that the greatest common factor of the first two terms is 3x. If you factor a 3x out of the first term, what you have left is x. If you factor a 3x out of this minus 3x, you're dividing it out to get minus 1, because negative 3 divided by 3 is negative 1. Looking at the last two terms, find the greatest common factor of those. By using the grouping method, we see that the common factor is a positive 2. Whatever sign is here, that's the sign that you're going to take out. When you factor out a positive 2 here, dividing out the 2 gives you x, and this negative 2 divided by positive 2 is a minus 1. Now we have two large groups here. We have the first group and the second group. Notice what they have in common. They both have this x minus 1 factor in common, and that is part of our factored form. One factor is x minus 1, and the other factor is what you'll find in front of those common factors, and you get 3x plus 2. So this is your trinomial written in factored form. And the method presented here is the AC method. Just a quick review, we began by looking at the A and the C, multiplied those together to give you negative 6. We found the pairs of factors of negative 6, and then we find the pair that adds up to the middle term of B. We split the middle term in this step here, and then we factored by grouping. The grouping, looking at the first group and the last group, and working through the problem, we see that by grouping, factoring by grouping, we get the two factors. One factor is x minus 1, the other factor is 3x plus 2. The way you check is by using FOIL, the first, outer, inner, and last. And when you do that, you get x times x, 3x is 3x squared. The outer is x times positive 2 or plus 2x. The inner is negative 1 times 3x minus 3x. And the last is negative 1 times 2, which is negative 2. When you combine the middle terms, you get the trinomial. This is our check step. This is our answer. Notice that this final step after the FOIL process is the same as what we started off with. Let's use the AC method to factor this trinomial. All right, let's begin by finding AC. AC is equal to 3 times negative 8, which is equal to negative 24. We list the pairs of factors of negative 24. Negative 24 can be written as negative 1 times 24, negative 2 times 12, negative 3 times 8, negative 4 times 6, negative 6 times 4, negative 8 times 3, negative 12 times 2, and negative 24 times 1. Out of these pairs of factors, we want to find the pair that adds up to the middle term of minus 10. that pair of factors is negative 12 and positive 2, because negative 12 plus positive 2 is negative 10. That's why we're selecting this pair of factors. And then we split the middle term. The first term is repeated as a 3x squared. The last term is minus 8. We don't do anything with those in the first step here, but we do split up that middle term, the negative 10x. We're going to write it as a minus 12x and a plus 2x. And then we use the method of factoring by grouping the first group and the last group. Notice that the first group's common factor is 3x. If you factor out a 3x from the first group, dividing out that 3x from the first term, you get x. Dividing out a 3x from negative 12x, you get minus 4. The greatest common factor of the last group of 2x plus 8 is a positive 2. Whatever that sign is, that's the sign that you're going to factor out. When you factor out 2 from the last two terms of 2x minus 8, you get x minus 4. Notice that these two groups have that common factor of x minus 4. That is going to be one of your factors, x minus 4. When you factor that out of both of those, what you have left is 3x and plus 2. So your other factor is 3x plus 2. This is your final answer written in factored form. Notice that if you were to use the FOIL process to check, using FOIL check, you should end up with what you started off with. Let's take a look at this example, factoring ax squared plus bx plus c with a less than 0. In other words, when a is negative. Often when we're faced with factoring a polynomial and the leading coefficient is negative, it's a good idea to factor out that negative and then factor the remaining polynomial. So this trinomial has no greatest common factor. There is no number that goes into all of those, but the fact that the leading coefficient is negative will indicate that we should factor out a negative 1 to begin with. When we're factoring out a negative 1, what will happen here is all these signs will change. The negative 5 divided by negative 1 changes to a positive 5x squared. The plus 34 divided by a negative 1 would be a negative 34x. And then the plus 7 divided by a negative 1 turns into a minus 7. So we're going to leave the negative 1 as its own factor, or we can just leave a negative without the 1, but a negative out in front. And then with the remaining trinomial that's in the parentheses here, we can use the AC method. The AC in this case, AC with A being 5 and C being negative 7, we get negative 35. We list the factors of negative 35, and we want to find the pair of factors that will add up to that middle term. Negative 35 is either negative 1 times 35, negative 5 times 7, negative 7 times 5, or negative 35 times 1. We want to find the pair of factors of negative 35 that will add up to the middle term of negative 34. And that pair of factors, negative 35 times 1, gives you negative 35, and negative 35 plus 1 gives you negative 34, and that's our middle term. So we're going to use the process of the AC method, splitting the middle term and then factoring by grouping. Each time we do that, we're going to have that negative out in front because that was our common factor that we took out in the beginning. Now we write the first term in the parentheses here as 5x squared. The middle term we're splitting up into two terms, the minus 35x and the plus 1x, and then the minus 7. Now we factor what's inside by grouping, looking at the first group. The common factor here is 5x, so don't forget that negative out in front, or just negative. We're factoring out 5x from the first group, and if you divide out that 5x from 5x squared, you're left with x, and dividing out negative 35x by 5x, you get minus 7. In the second grouping here, the plus 1x minus 7, the greatest common factor is 1. So we are factoring out a plus 1, whatever sign that is. We're factoring out the plus 1. And then when you factor out a positive 1 here, you're dividing by 1 to get x minus 7. And then again, we have this whole big parentheses, the blue parentheses here with the negative out in front. Now we look at these groups. Notice we have the first group and the second group. They both have that common factor of x minus 7. That is going to be one of your factors, which is the negative out in front. And one factor is going to be x minus 7. And the other factor, what's left over when you take out that common factor of x minus 7 with those two larger groups, we get 5x plus 1. Now when you're doing these factoring problems, it's important to note that the factors, the order of the factors doesn't make a difference. So this answer could also be written as the first factor of 5x plus 1 and then followed by the factor of x minus 7. Multiplication is commutative, so the order doesn't matter. So either one of these would be correct. And again, we did put that negative out in front. We factored that negative out in the beginning, from the beginning, because it had a leading coefficient that was negative. All right, in this case, we're factoring a trinomial that's in the form of ax to the fourth power. So the way we're going to get a fourth power is by, if we did the FOIL process in reverse, if we had a squared term times a squared term gives us an m to the fourth term. Otherwise, it's still in the trinomial form, and we can use the AC method. The a in this example is 10. If a is 10 and c is equal to negative 10, then AC is equal to negative 100. We want to find the pairs of factors of negative 100, and there are a lot of them. So rather than listing out all the different pairs of factors, you can list out a few and find one that will add up to negative 21. So you can say that negative 25 times positive 4 would be one of the pairs of factors in your long list. And this one, if you add up negative 25 and a positive 4, you do get negative 21. So this is our pair of factors that will multiply to give you AC and add to give you the middle term. Now we factor by grouping. The first term is still 10m to the fourth. The last term is still minus 10. That middle term, you're going to split the middle term into a minus 25m squared and a plus 4m squared. Then we are going to factor by grouping, looking at the first group and the last group. The common factor of the first group is 5m squared. When you factor out the 5m squared, you're dividing 10m to the fourth by 5m to the second, and that'll give us 2m to the second power. When you're dividing negative 25m squared by positive 5m squared, you will get minus 5. Looking at the last group, the common factor here is a plus 2. And when you factor out the 2, dividing out the 2, 4m squared divided by 2 is 2m squared, and minus 10 divided by 2 is minus 5. Now you can see the larger groups here both have that same common factor of 2m squared minus 5. That is going to be one of those factors, 2m squared minus 5. And then what's left over when you factor the 2m squared minus 5 is 5m squared plus 2. By using the FOIL process, you can check to see if your answer is correct by working through and getting the original trinomial.